Hello everyone, welcoming you to Shaurav's classes, and today we are looking at the University of Hyderabad and Economics 2021 entrance paper, question number 17. So the question says, consider an economy with two goods. The set of all possible positive relative prices is given by this set capital P, which is such that P1 plus P2 is equals to 1. Then identify the correct statement given the properties of set P. P should be convex, part 2 P should be bounded, P closed, P compact, and P empty. Now, obviously, the terms might sound a little bit difficult to understand in most of the cases. So, what we'll do, we'll go actually option wise so that it's easier for us to actually understand. If you look at the first one, so if I just write it once, what does P, the set P, indicate? It basically contains all those prices P1 and P2 where individually both of them are positive and both of them add up to 1. This is what it contains. So essentially what we are trying to do is that if I take P1 and P2 on each of the axes, it's basically a straight line, right? So if you just draw a straight line, negative intercept 1 each, then this basically indicates P1 plus P2 is equals to 1. This is what it is. So obviously since it's a straight line, it is convex. So 1 is definitely correct. Now if you look at the options, luckily what we can see that 1 is true, that is present in only part C. And if you just want to cross check part 2 as well, that P is bounded, yes it is, because this is bounded by two bound coordinate axis values on the two ends. So yes, so this is your option part C to the answer. You need not bother about the others simply because one is correct and that is only mentioned in as a part of option C. So nothing else is actually possible. So hence by eliminating the unwanted options you get option C straight away without bothering much about the concepts that I mentioned over here. Okay. So now let's move on to another question of the paper, which is question number 31, which says that let V and W be random variables such that the correlation between these two is positive but less than 1. Okay. And let x be equals to 2 times v minus 4 and y equals to minus 0.5 w plus 2. So arrange the following in increasing order of magnitude of correlation. So these are the four things that we need to arrange. Now if you look at something that x is not related with v, is not related with w, right? So because x is defined only in terms of v, fine. So it's not directly related in that way. So essentially, therefore, correlation between x and w will naturally be 0. You can understand that there is no calculation that needs to be followed to understand this. Similarly, y is defined only in terms of w, so it has no connection with v. So correlation between y and v is also 0. So these two are straightforward. Okay. If you look at the correlation between x and v now, so therefore x is equals to 2 times v minus 4. So that means just before doing any calculation, what you can see is that if v increases, that means x will increase. Therefore, the correlation between x and v is actually positive. That is what we can clearly understand. And if you look at the relation y equals to minus 0.5 times w plus 2, that means if w increases, then y will fall. Therefore, correlation between y and w is actually negative. So since you're only told to order, the negative term is the slowest. So it will be the the fourth one will be the lowest. So if you look at the options, it is part D, which shows that 4 is the lowest. Then the 2 and 1, both of them are 0. So then they will come in order, and that will be followed by number 3, and hence your correct option is option D. You need not actually go into the calculation of correlations to get to this answer. A very tactful observation of these two expressions will give you the answer straightforward. So moving on to another question of the same paper, University of Hyderabad Economics 2021, and question number 45. So consider a society of finite number of individuals 1 to n facing a finite number of states, alternatives z1, z2, zt, t greater than equals to 3. Every individual in the society is able to unambiguously rank all these states with each other. We say that an alternative zk is Pareto optimal if first part says each individual in the society considers zk to be superior than any other state. Option B, every individual in the society considers zk to be at least as good as any other state. Option C, there is no state which is considered at least as good as zk by everyone and strictly better than zk by at least one individual. And option D, every individual in the society considers zk to be the least as good as any other state, and with respect to every other state zi I not equals to k, there is at least one individual who strictly prefers zk to zi. So essentially, this is a question directly from theory. And if you just closely look at the options, it's essentially the way in which it's written is what matters. So the correct option will be C. There is no state in which is considered at least as good as zk by everyone and strictly better than zk by at least one of the individuals. So only then it is considered Pareto optimal. If you have looked at some standard micro books like Halberian and all, the line goes like this: there is no way to make anyone better off without making someone worse off. So that is the essentially the same interpretation is coming out from option C, and hence the answer to question number 45 stands at option number C. Thank you.